a low pH, that should be a parentheses mark. Endothelium, remember endothelium is what we call the simple squamous epithelium that lines blood vessels. And so they'll make this chemical in response to carbon dioxide and lactic acid, and that affects the smooth muscle cells and causes relaxation. And with a larger lumen, we have more blood flow. Okay, so that's really all this is referring to right here. And of course, the larger lumen is going to mean lower blood pressure. Okay, it's going to flow more slowly and give more time for that oxygen to come off. All right, so what I want to do now is look at, define a couple of terms on page 118, and then look at 3 hormones. So you really don't have to, just ignore, I think would be the easiest thing. Ignore pages 122 through 128, and just listen to probably what I write on the board, okay? Rather than say, learn this, don't learn this. So I want to talk about, I'm going to give you the definition of 2 words, and then I'm going to talk about 3 hormones. Much more briefly than they're discussed in your lecture notes, and we'll cover them in that detail when we get to the urinary system. Okay? So, the 2 words I'm going to talk about are baroreceptors and chemoreceptors. So a baroreceptor is a receptor that detects changes in what?
Pressure.
Pressure. Okay? And the major site of baroreceptors for blood pressure are found in the aortic arch and the internal carotid artery. Right here and right up here. Okay? That's also the site where we find chemoreceptors. And the chemicals that these are most sensitive to are hydrogen ions, carbon dioxide molecules, and oxygen molecules. So it makes sense that if the body tissue is the blood vessel, the arteries, start again, the arterial blood is low in oxygen and high in CO2, that we need to move the blood at a faster rate through the lungs to get more oxygen and get rid of the CO2. So in response to that, the heart beats faster, okay? If blood pressure is too low, then we're not going to get fluid to the organs at a fast enough rate to supply oxygen. So baroreceptors detect low or high blood pressure, and again, through primarily autonomic reflexes, will cause the heart to beat more or beat less to change our cardiac output, and will cause the blood vessels to constrict or to dilate to change blood pressure. All right? So that's the chemoreceptor baroreceptor reflex. And we'll cover that again in more detail when we do the respiratory system. But I want you to know what chemoreceptor and baroreceptor mean if you forgot from Bio 430. So these are nerve endings that are present here and here. And they travel with the glossopharyngeal nerve back to the cardiovascular center in the medulla. And from there will affect parasympathetic or sympathetic changes, just like we've already talked about. So in that previous slide where I was telling you to put the arrows in, and it said high CO2 or low O2 or high hydrogen cause sympathetic nervous system to activate, this is why. Okay? And that's the extent that you need to know about that. Don't worry about whether it's short-term or long-term. Okay, just what those words mean. Okay, any questions on that? And then I'm going to look at the 3 hormones. Okay. So I think I need all 3 boards. All 3 boards. So some of these hormones you've heard of before because we talked about them when we did the endocrine system. And the first hormone involves the hypothalamus. And via the hypothalamus, the posterior pituitary gland. Okay? And a particular hormone made by, we only have two, made by the hypothalamus and released by the posterior pituitary is anti-diuretic hormone. Okay? One of the effects of anti-diuretic hormone is it does vasoconstriction. Obviously, that's going to increase blood pressure. It's going to change the diameter of blood vessels. Okay? The other major mechanism by which antidiuretic hormone increases blood pressure is its effect on the kidney. And again, the mechanism of this will go into more detail when we get to the urinary system. But blood is filtered in the kidney. That's why it's so important. Blood pressure is so important to the kidney. And that means small particles are allowed to pass through. And fluid, water passes through. And we call that mixture filtrate. It's not urine yet, okay, because we have to concentrate it and change what's in it and what's not. But in the kidney then, we have this filtrate passing down through a series of tubes to empty into what's eventually going to become the ureter. On either side of all these tubes is an increasing concentration of particles, primarily salt, sodium and chloride ions. And notice it's getting higher and higher in concentration as this fluid is leaving the tubule. When it comes into the tubule, you don't have to memorize these numbers, but when it comes into the tubule, it's of a osmolarity of 100 milliosmoles. Blood is typically 300. So if nothing happened, if we left this filtrate without doing anything, you would have a very dilute urine. It'd be almost clear when you looked in the toilet bowl. Okay? And if you drink lots and lots of water, if you drink 5 gallons of water a day, that's what's going to happen. You're probably wearing a pad or a diaper or something. Okay? Now, let's say that you haven't drunk any water since this morning when you woke up. Your body needs as much of that fluid in the urine as possible. And so it releases anti-diuretic hormone. Anti-diuretic hormone functions to cause these cells, which I've only drawn a line, but these are cells, and they will add water channels available to the filtrate. So anti-diuretic hormone causes the addition of water channels known as aquaporins in the kidney. Now, let's say that our concentration of particles out here is 300. If I have open water channels, those extra particles are going to cause water to be pulled out of the collecting ducts of these channels. It's like putting sugar onto strawberries. It pulls the juice out of the strawberries, okay? And the higher the amount of sugar, the more juice is pulled out. So if I have water channels open, then I'm going to pull water out of these channels, and I'm going to make my filtrate more concentrated. Now as I move down here, let's say this is 600 milliosmoles. This is now 300, so when it gets to 600, even more water is going to get pulled out. All right? So our body has the ability to increase the concentration of the filtrate from 100 to 12 to 1400 osmoles, almost 12 times. what it comes into, the filtrate X. And that's what antidiuretic hormone does. Where do you think all that water goes that we're taking out of the filtrate? It's not going into the urine. So when you go to the bathroom now, it's going to be a small amount. It's going to be very, very, very dark yellow. Okay? Where does that water go?
Back to the blood.
Back into the blood. So a result of this is to increase blood volume. And when we increase blood volume, what do we do to venous return? It increases. And when we increase venous return, what happens to stroke volume? It increases. And when we increase stroke volume, what happens to cardiac output? And when we increase cardiac output, what happens to blood pressure? It increases. Okay? So increasing levels of ADH causes an increase in blood pressure because we have more blood in the body. Anybody know the effect of alcohol? Do you pee more or pee less with alcohol?
Pee more.
More. Rather than affecting the kidneys directly, alcohol blocks ADH release. So you don't see all of this happening. Okay? So it's not going to increase blood volume. It's not going to increase venous return. Okay, so that's one molecule, antidiuretic hormone. Okay? Another organ that's involved is the adrenal gland. Obviously, we can tie it back to the hypothalamus via cortical-releasing hormone. Okay, but I'm not going to go quite that far. And adrenal gland releases a molecule known as aldosterone. It's a steroid hormone. It also works on the kidney. And it causes the kidney tubules to increase sodium reabsorption. All right, so aldosterone increases sodium reabsorption. So the sodium doesn't stay in the urine. If you haven't heard it yet, you will. Sodium is Mary. Water is her little lamb. Wherever Mary goes, her lamb is sure to follow. Wherever sodium goes, water follows. All right? So if the kidney tubules are increasing their reabsorption of sodium, water reabsorption increases. And now everything else is the same. If water reabsorption increases, blood volume increases. If blood volume increases, so does venous return, so does cardiac output, so does blood pressure. So the end effect is the same, the mechanism is different, all right? One uses sodium already in tissue fluid to pull the water out. The other takes the sodium that's in the filtrate out and water follows with it. Okay? But both have the end effect of increasing the amount of fluid in the blood, increasing venous return, and increasing cardiac output and blood pressure.
And both are in the tubule, right?
Actually, this effect occurs in the nephron rather than the collecting duct, but I'm not worried about that. As long as you know they both go to the kidney. Okay? The third hormone comes from the heart. There's actually a similar molecule in the brain as well. And this is known as atrial natriuretic peptide. No big surprise. It also works on the kidney. Atria, we're talking about the atria of the heart, okay? What do you think natriuretic refers to? What's that? Sodium, okay? So this is going to occur when there's increased venous return It stretches the atrial muscles. And to stop that from happening, the body gets rid of sodium, which gets rid of water, which lowers venous return and lowers blood pressure. So this has the opposite effect of aldosterone. Okay? It works on the kidneys, but it works on the kidneys to decrease sodium reabsorption, which I think you've got this by now. Is going to decrease water reabsorption, which is going to decrease venous return, which is going to decrease, did I leave out stroke volume here? Which is going to decrease stroke volume, decrease cardiac output, and decrease blood pressure. So, if we compare two individuals, an astronaut out at the space shuttle, okay, so he's Russian, but anyway, out at the space shuttle, versus a nurse who's working on the floor. Which one is more likely to have an elevated atrial natriuretic peptide level? What causes A and P to go up? Stretching of the atria. What causes the atria to stretch? Increased venous return, blood volume. So a nurse on the floor with gravity keeping the blood flow in his or her legs, causing varicose veins. There's too much blood down there. Versus an astronaut who's not affected by gravity, and therefore blood flow is evenly distributed across the body. It's going to have increased venous return because he doesn't have the opposing gravitational force. So he's going to have, or her, have a higher A&P than the nurse. Does that make sense? Okay. Interestingly enough, A&P is also increased, and it makes sense. It increases lipolysis, fat breakdown. So studies have been done with people immersed in water. Again, even blood flow distribution. A&P goes up, increased fat breakdown. So maybe for insurance, you can put in having a new pool built because you needed to immerse yourself in water and elevate your A&P and get lipolysis increased so that your blood pressure goes down. You think that would work?
Like how long would you have to do?
I don't know. That's where the rub comes in probably. You have to immerse yourself there for 2 years and see 2 pounds of weight loss or something. Okay, so this is where we're going to stop. Aldosterone, an antidiuretic hormone, both increase blood pressure by increasing venous return. Atrial natriuretic peptide decreases blood pressure by decreasing venous return. Okay, decreasing the amount of fluid volume. All right, so we'll stop there. Why don't you take a short break and we'll do case study at 4 o'clock. Okay? And then lab involves blood pressure and pulse. Pulse you can do at home. If you have a blood pressure cuff, you can do that at home as well. All right, otherwise I've got blood pressure cuffs and stethoscopes and stuff over here. And then I need to give you directions on venous pressure as well. Okay?